It's very nice to be invited here, and it's very nice to see so many of you here. I will give you a talk about one very successful research project that I and my PhD student Rickard Berntsson Svensson has been working on now for a couple of years. In collaboration with Son Ericsson, funded by Vinnova. And the research is conducted in the context of the EASE project, which is a big research effort at Lund University, and also Blekinge Tekniska Högskola. So first I would like to get a feeling of what type of people are you, so to say. How many of you are involved as developers in product development, software product development? Okay. And how many of you are involved in decision making or management around software product development? Oh yeah. So those two questions cover a majority of the people. So okay, how many of you have quality aspects that are important when you compete on the market for your products? So the quality of your products are important, yes. What I will talk about now is a way of how to increase and align the debate within a company about what quality should we deliver ahead. And when we have been out and researching together with different companies, we have often seen that the most difficult requirements are the ones related to quality, and how to define quality is very difficult. So what we have tried to do is to make a very simple model, actually, where we have simplified a lot. So it will not be perfect, but the strength with the simplification is that it will be easy to learn and rather easy to use. And there is also a scalability issue that I want to discuss with you. Feel free to interrupt me. We have 50 minutes, and I'm very happy to make this an interactive session. I can go through my slides in different orders, etc. I will adjust to your interest, so don't be afraid to interrupt me or ask questions or so. Are you hearing me perfect, or is it too loud, or you have to? This is good. So, if you are going to remember one thing from this talk, it's this picture. So our first assumption here is that quality is not linear in the sense of its benefit. So it's not a linear relation. If you get more and more quality, how much benefit you get. And obviously this function here between quality and benefit of the quality is very difficult to estimate. It's about future expectations of the market. It's about the technology development, etc. Of course, it's difficult to estimate this. So what we have done is to try to simplify this relation by defining 3 breakpoints that can be used as reference points when setting requirements. That can be used as a common way, a common understanding, a shared picture of the quality landscape for different quality aspects of your product when you are debating this within the company. So the 3 breakpoints are utility, differentiation, and saturation. And we have worked a bit with trying to find easy semantics for this point. So this is the version after a couple of trials. But the red point, utility, means when the quality goes from being not really usable to being usable. So if you take, for instance, the startup time of a mobile phone, if it takes like 1 hour to start up the phone, it's really not usable. People will not use it. And if we go down to 1 minute, it's probably above the utility point. So somewhere there is a point where people accept this. And this might change over time depending on the acceptance of the market, etc. But there is some quality here where we can say at some point approximately where we go from not being really acceptable on the market or being usable, so to say. And the next point, differentiation, is the wow point, when it gets to be an argument, a specific argument for this product over others. It gives a competitive advantage. So now the quality has risen so that you can say that, oh, but this is better than this and this product, and you can use it as an argument when you market it. And then we have the overkill point, when there is no need for actually, if it takes 1 microsecond, or if it's say 2 microseconds, it's definitely overkill in startup time for a mobile phone. So if you go beyond the saturation point, you of course have placed your investments in the wrong part of the product development, because you're investing stuff that will not give extra value to the market. So you really want to know that you're not passing the saturation point if you have limited resources. So is this a reasonable image of the quality landscape? Could you agree with that? Yeah. So I will now take a step back and try to... The picture I showed you with the breakpoints is the gist of the methodology, but there are quite a few things around it. So I will get back to that picture. But first I want to give you a background for why we have done this. The research has been conducted together with now several companies, but it started at Sony Ericsson. I've been part-time senior researcher at the CTO office working with requirements engineering, process improvement, etc. And if we take a step back and look at 10 years back or even further, you can see that there, and compared to today, you can see that there has been a tremendous shift in the embedded systems industry from kind of isolated product developers that compete, to a landscape where there is much more complexity in the relations between the different players on the market. So you both collaborate and compete at the same time. And in order to deliver all the massive amount of code we need to deliver, we need also to specialize. So there are platform deliverers that specialize on specific components, and they deliver to competing companies with all that comes with it in terms of what you need to do in order to have a clear business cut, etc. So this landscape here, all the interfaces between all the players, where there are integrators that have platform providers that deliver to competing integrators, etc. You need to have a very good requirements interface. You need to be able to communicate requirements. And the requirements that are the most critical in these cases are often the quality requirements. The requirements on performance, the requirements on reliability, the requirements on extendability, things like that. Unfortunately, those requirements have also proven to be the most difficult to tackle, in the sense that there is a very big difference of quality requirements depending on your domain, the product you're working with, the way the company is organized, the scale, and then there are many different types of quality requirements that actually needs different treatments. So this complexity increases very much when the scale increases. So scale here is an issue. So this slide tries to give you an idea of what happens when you increase the scale. For the last couple of Heartbeats projects, or the last couple of platform projects at Sony Ericsson, there are requirements in the order of magnitudes of several tens of thousands requirements on one platform project. And it reflects all the intricate complexity of the integration that is needed from different subcontractors as well. Yes.
Just so I can put this into perspective, so what is a requirement in your language?
Yeah, in my language, a requirement is can be on different abstraction levels, but it's either a candidate for something to implement or a decided thing to implement.
So it's a feature of a system.
It can be a feature on a high level that is visible externally, but it can also be a more internal system requirements that support that several system requirements might support the feature. So thank you for the question. I should be more clear. I've been working in requirements engineering since the beginning of '90s, so the word requirement has kind of shifted meaning over the years. But the consensus now is that the word requirement is very general. It stands for, if you don't qualify it more, it stands for the information and the decision around it that governs what you are going to develop. And also you might need to change the stuff along. So a backlog might include requirements. A user story might be called a requirement in that sense.
This is sort of a 1,000 user stories, or is this on a more sort of technical level?
On the companies that have this order of magnitude, they have the most of the requirements, the bulk of the requirements are probably broken down system requirements. And the fan out from a high-level feature level to system requirements can be 1 to 10, 1 to 100. So if you have like thousands of features, you might have tens of thousands of system requirements. But this is different in different companies, how much the fan out from the high-level requirements to the detailed requirements are. So I'm not saying this is my rough picture of what happens when you increase the scale that I was talking about. But I'm completely aware that requirements, the abstraction level and level of detail requirement might very much affect the number of requirements you have, of course. And this is also a time issue, because in the beginning you might have higher level requirements that are broken down into many requirements, etc. But never mind that. If you are going to manage a chunk of information that tells you about something you're going to develop, you have an entity that needs to be managed and needs to be checked and decided about and considered if it should be split or joined with something else, or if it's good enough quality, if it's complete enough, etc. So when I say requirements, you can interpret this as a chunk of information that is used in the process or the debate of what we are going to build. So it's a very, very general definition. Okay, so when you have a small-scale requirements engineering, meaning that you are working with very few entities like features or user stories or system requirements or whatever, this one person can manage this, can keep track of it. It's like the scale that beginner programming at the university, the type of systems there, or even the type of systems that are published in books about software engineering sometimes is on this scale. If you come up to a medium scale of 100 requirements, this is feasible, but the effort starts to get large, because okay, it doesn't seem to be very much with 100 requirements. But if you think about the interdependencies and the combinations of requirements and what effects that can come with that, then it actually can require some large effort to understand and penetrate and manage this amount. When you go up to 1,000 requirements or 1,000 information chunks that are governing your development, it starts to get practically unfeasible to manage also all the interdependencies. So assuming that we have only pairwise interdependencies among thousands of requirements, we get approximately a squared number of interdependencies. And 1,000 squared is quite a lot. So the typical thing we do then is to try to raise the abstraction level by bundling related things together and manage the bundles. So then we reduce the numbers again. And it might be feasible then to manage the interdependencies among the bundles, if you're following me. But if you go to the next level of complexity, the next order of magnitude, then even the interdependencies among the bundles, the more generalized groups of requirements that we are handling together for managing complexity, even those get too many. So what we could do is to increase the bundle size, but then the bundling is kind of meaningless because we have such a big bundle, like we say, all requirements about video. I mean, it's okay. All requirements in a mobile phone about video. That's a too big bundle because you need to get more detail to have it useful. So you see, it's really impossible to manage all interdependencies. So you need to prioritize and only select a few critical interdependencies extra. And here you are in a very complex situation if you go up the scale. And this is increasing dramatically, at least in quadratically, but probably even worse, because you don't only have binary relations or interlinear relationships between requirements. You have triples and quadruples, etc. So in a big, assume that you are working in a big context as either an integrator, subcontractor, or where there is a collection of companies working together to deliver a complex software-intensive product. There are lots of things that needs to be done. You need to consider the market. You need to do product planning. You probably have divided the development in platform projects with the longer life cycles, and you have product projects with shorter life cycles in order to attend the market, so to say. The work we have done with the QUPER model is in this domain here, when you go from the long-term, often line-controlled, strategic decision-making and preparation to the projects, to hand over that decision-making to the projects. So in road mapping for application platform development, that's where we have used it. But I think that the model is general enough to be used also closer to product releases and also in projects with shorter increment cycles, like in a Scrum or XP or other agile types of project where you have shorter increments. I also think that this is, and we have some indications already, but the main trial of the method is in the early planning of projects that are year-long. Okay. So when you're going to improve the quality requirements, you need to recognize that we are actually adding a definition compared to when we are discussing more features that are more pure functional related. So if you take a feature, normal feature, you often discuss its cost, often in terms of effort of development, and its benefit or its value. But the quality adds another dimension, namely the level of quality, which means that you need to, when you make decisions, need to not only take into account the benefit or the cost of it, but also the level of the quality, which makes it more difficult. So understanding these three dimensions is important in order to answer questions like this. I mean, it would, of course, be possible that we invest just a little less to get the quality, but it's almost as valuable. Or, of course, we could invest just a little less, but it turns out to be very much cheaper. And this goes back to the non-linearity property that I talked about in the beginning. So understanding these properties that you have of your own products that are specific to your products is critical in order to gain something from this non-linearity, so to say. And the idea here is basically to try to find breakpoints that are interesting to answer these types of questions. I will focus in my examples on performance. The area of so-called non-functional requirements, I don't use that term that often because non-functional could be misinterpreted as something that does not function. And it's so from a historical perspective, it's like this, that in the early days, like in the 90s when requirements engineering was founded, everything was focused on functionalities almost. And then people realized that there are lots of other requirements, and they bunched them all together and called them non-functional. But the term quality requirements is much better. But here is a picture of a standard called ISO 9126, and it has followers that tries to define different types of quality aspects, tries to standardize the categorization. And it turns out that this is quite problematic because different companies have different terminology for this, and it's not always aligned with that standard. For instance, in the software industry, many talk about performance in the sense of speed or memory utilization, things like that. In the standard, it's called efficiency. But I will use performance as an example because it's a very typical quality aspect that is on a sliding scale, where you can have more or less. If you talk about a more complex quality aspect such as usability, it can be broken down into different aspects, of which where performance is one that is related, of course, to usability. So I'm making a simplification here that you should be aware of. And you should also be aware of, even if we take only one aspect of this very complex issue of quality, like performance, this is different in different domains, for different products, for different market segments over time. So the perception of quality changes, and the way you can produce the quality depends on your processes and your organization, and the way you talk about quality depends on your history and your way. So it's completely different from embedded software or pure software or open software might place specific challenges on quality, etc. And this you have to understand and learn yourself. You have to know enough about your business to understand what's specific about your quality levels. We have also made an investigation. I have a list of references by the end of the presentation where you can dig out papers that we have been working on in quality requirements. One of the things we have done is to try and to empirically study how, to what extent industrial requirement specifications or the like have quality requirements in there. This is a study from a big specification over time where over 2,000 subcontracting requirements have been analyzed. And there are approximately 40% of the requirements that are related to quality, that either have quality only in them or quality combined with functional aspects. Is that a lot? Or is it not? How many do you have in your specifications? How large fraction of your specifications or other type of information that you use to define what you're going to develop have non-functional or quality aspects in them? You don't know? 50-50. So the question is how many should there be? Well, I've just said that it depends. But one reflection you can make is that if you have one feature, it's probably true that this feature has more than one quality aspect. If you have one functional ability, a thing that the system can do, it probably has more than one quality aspect. So I would assume that this is very low in terms of completeness. But then we also need to think about the scale that I was talking about. I mean, we need to prioritize. We cannot be complete in the sense that we have everything, because it will be too much. So we need to prioritize. So maybe it's the case that there is only one important quality aspect, really important quality aspect for each function. I don't know. It seems like it's still a bit low. What you can see here is that it varies a lot over different areas. There are 28 different areas, subdomains of this specification, and it's very different. Some areas have much more quality issues than others. So our main challenge here is to, if you compare to functional requirements, I think that there are quite good methods out there and used in practice as well to put value against cost for functional aspects, for features. There are different types of ways to prioritize, and you can plan according to that. There are different types of models in different paradigms, so to say. But the challenge here is to be able to compare apples and pears, in the sense that we also want to plan, release plan, and decide about quality aspects that have these three dimensions, and do that together and against the functional aspects. And that's the challenge. How can we make this scoping not only of functional aspects but of quality aspects? And that's what we're trying to address with the method that we are doing. So the basic assumptions again, quality is to some extent continuous. Of course, you can have discrete levels of a scale, but it's a kind of more or less thing compared to a functional aspect that you have or don't have. This is a simplification as well. But a basic assumption, this simplification, is that quality is something you can have more or less of. And it's non-linear in its relation to benefit. So we want to have a method here that is not too fancy and too complicated to not be easily usable. And we also don't want to be very reliant on specific, very certain estimates, because we acknowledge that this is, to estimate quality is an uncertain business, so you need to cope with uncertainties. And you should be able to tailor it to your domain. And many methods that are come is a kind of a new religion that try to overthrow everything. That's not the idea here. The idea here is to be able to use this as an add-on to whatever you have, to combine it with the other stuff you have, if you want to fill a gap in quality requirements. So here I will show you in this slide the complete method in an overview, in a helicopter overview. So you have already seen the benefit view with the 3 breakpoints. There are 2 more views. The cost view. Here is the idea to characterize the relation, the non-linear relation between quality level and the cost, which is often, of course, related to the effort, the investment in engineering brains, so to say. And this, in our studies, we have found that this relation is, in principle, to some extent different than the others, in the sense that what seems to be important is the shift between the steepness of the curve. So some parts of the curve, you can, with rather small optimizations, get an increase in quality without investing that much. But then suddenly you hit the roof, and you need to do something. You need to reorganize your architecture, or even add better hardware or so. So there are different parts where a quality increase have different cost penalties. And when the cost penalty increases steeply, we call this a barrier. A cost barrier. Yeah. Yes, we have investigated this. The whole work started and has been applied in several different subdomains at Sony Ericsson. So it's embedded systems, but there are different subdomains. Like positioning is very different from network signaling, for instance. And also we have currently a product software company in Netherlands that are trying it out, and they are more information systems like. And actually application and implementation of the model in the sense of which quality aspects we decide is very domain dependent. But the concepts of the model seems fairly general. So I would love to see if anybody would like to test this and give us feedback on that. It would be very interesting to see if it's applicable in your domains. Okay, the third view is called the roadmap view. And here everything is put together to make a basis for decision making and to document decisions. So the idea here is that we look at the quality levels, and here you see that the y-axis is abstracted from. So the actual estimates of the level of benefits, however you measure that, possibly perhaps in dollars, I don't know, or euros. And also the cost is sometimes very difficult to estimate exactly. So this roadmap view is not definitely relying on the actual estimate. So the idea here is to use the quality scale that you have defined. So imagine that you have a product, and for that product you have decided or defined a set of important quality aspects. For each of those quality aspects, you can do a roadmap view to say what are your future targets in terms of quality. And these future targets are calibrated against the concepts in the model that you have found. So you get the calibration of what you mean with 13 in quality. So you need to define a scale here. For instance, startup time for the music player, or time to first fix in a positioning software or whatever. And then you need to find your calibration points in terms of the market expectations. Where is the utility? Where is the differentiation? When does it get wow, and when is it overkill? And then you need to understand approximately where your cost penalty increases a lot to raise the quality, the barriers. And then you can start to talk about your targets. And we can also do this in relation to current products and competitors' products. So in this way, we connect together the relevant things that you need to understand to decide for the future evolution of your products. Of course, the breakpoints change over time. So this is an evolutionary, iterative exercise that you need to visit and think about. And in our studies, we have found that the differentiation point seems to be more depending on the market progression here, the expectation progression, while the utility and saturation points are kind of more stable over time. But this is probably very dependent on the type of market, the maturity of the market. If you are heading dead on in a price competition mature market, it's probably very different than if you're on a new green field for a technology. Okay, we should also be aware that the estimations here are uncertain. So what we have used is that we have at sometimes tried, instead of saying a specific point, talking about intervals. It seems like experts have easier to talk about, okay, it's between this and this, rather than setting down the foot and say it's exactly this. And it's also in line with the view of quality as a sliding scale, and it's not an exact science. We're trying to predict the future here, so it's difficult, of course. And what we can talk about different targets, and these are actually the elements that we can put together when we discuss and balance, should we do this feature or should we invest in this quality increase? So we can compare apples and pears with the targets. So for instance, we could say, should we have a very difficult target for this quality or should we have a balanced target? Well, we need to invest in this new feature instead, etc. The debate can go on, but now it's more qualified because you have calibrated against the market expectations, you have investigated your cost barriers. And you can talk about this with a common language among tens or hundreds of people involved in the decision making and the preparation of the decision. So we have developed a step-by-step guideline. I will go through this quite quickly so that you will just get a feel of how it can be implemented. There are much more to read about this in the papers we have published, and also if you want to try it out, don't contact us and we can give you more. But the idea here is to make it a simple stepwise description of the implementation. But of course, this will be iterative, and some of the steps you might iterate more. Some of the steps might be usable in the next step, etc., etc. So this is a simplification. But so you need to define the quality aspects. You need to estimate the current product quality and also relate it to competing products. This is good to do in the beginning. It turned out that this was a way of calibrating as well to see the market and invest the competitors, etc. And then we need to define the relevant quality aspects and also the breakpoints and the barriers. And then finally the candidates for the requirements, basically, the targets that we are candidates for requirements. So when you are defining the quality aspects, you need to qualify the aspects with the specific situation, with the context. So you need to narrow it down to a certain feature, perhaps a certain market segment if you have several products with different quality profiles for different segments. You may also want to investigate the competitive scenery, so to say, and also the relation to hardware, etc. So all this might be important when you define your quality aspects. And then there are a number of things you could consider when defining those. And I've talked about some of them. I mean, we will know in the future that hardware will give us more opportunities on the software side. We also know that users' expectations evolve, etc. So typically we need to specify which feature we are talking about. And this feature might have several quality aspects. Here is one example. It's a mobile TV time shift buffer size. And we defined a measure, and this might be more or less difficult. Some measures will be fuzzy, like on a ordinal scale, subjective even, like high, low, medium, things like that. Others can be measured in minutes. The next step is to identify the reference levels, and this is turned out to be a good first step before you do the breakpoints, so that you first see what's out there on the market, what's the current quality level. And it also gives you objective measures if you take the current market, because the other things are estimates of the future, which is difficult. But the current products, you can actually often measure or see the actual objective quality. And then you elicit the breakpoints that I've been talking about. And typically, you define the breakpoints in terms of the scale that you have been able to define for that quality issue. You can also have very much use if you explain why, or you have estimated that the utility breakpoint is here. So all the information you use when you try to elicit this information, if you explain why, it will be much easier for others to understand and also to adjust if there are errors, or to adjust if time changes those breakpoints. So keep the rationale. The next thing is the barriers, and here it turns out that the first barrier is often easier to estimate than the coming barrier. So the barrier beyond the barrier, when I've talked to experienced systems architects, it gets much more difficult because it depends on so many things and the technology development, etc. So this will not be an exact science, but it's better to have the gut feeling than to have no feeling at all, so to say. And then set the candidates. And one idea is to not just set a specific point target, but to have an interval. And what we have talked about here, found useful in the talk with the practitioners, is that having an interval with a good and stretch target. So when you then do the testing and see if you have fulfilled the target, you can see if it was okay, if it was acceptable in terms of what we have said, or if you even managed to stretch it. And it's sometimes very difficult in advance to know exactly where we will be, as there are so many uncertainties. But it's very good information to know, both for the developers and for the testers, what is the good and the stretch target, because it sets the scene and calibrates the view on quality. Okay, so what are the expected gains? And well, making hidden, previously non-communicated in consistent ways, features, requirements, user stories, etc., the information around what we are building, making this explicit in terms of quality. That's a major gain. And I've seen many companies where the quality issues are actually discussed in a way that people misses the points because of communication problems, so to say. So a coherent terminology gives a more qualified scoping debate. And also we connect this to the market research and the competitive scenery that we have, and to talk really about where we position ourselves against competitors, which I think is very important. We're not developing software in isolation. We should, if we're doing commercial product software development, we should always have the market aspects into the mind, so to say. And it also actually supports change management, because what happens over time is that it changes, but if we have done the homework of defining our quality aspects, this can be reused over and over and evolve as the system and our understanding of the domain evolves. So and when things changes, we have documented our targets, and we can change our targets easier in terms of understanding their implications, etc. And hopefully, of course, this gives more profitable products as we are making better decisions, hopefully. So there are quite a few studies published about this. Here is a list of reference. Maybe the easiest accessible is the IEEE software article above. If you have difficulties in encountering this, you can email me, and I can try to dig this out, the papers. So there are different studies. So my presentation is based on part of this, but there are more to read. And if you're interested in trying it out, you can contact me and Richard Benson. He's currently in Australia trying out QUPER on a visit in Sydney, but he will be home by Christmas, and in the spring it's a good timing to get a partner company, more partner companies to validate and make experiments with this. So if you would like to join research efforts at the university in some of the different constellations or opportunities that we have for that, you are welcome to contact me and make a case study of QUPER, etc. It's a good point in time for the research to do that, so we're very keen on getting collaborators here. So that was my talk. I hope it was understandable. Is there any question or any counterpoints or any arguments against or any weaknesses you have found? Or yes? A very, very good question. So the question was, how do you handle requirements that interact in a negative manner. So you cannot have both. And that's the major weakness and but also the strength of the QUPER model. We have done some work in interaction management, but all the things that we have found and worked on have been actually too complicated for the complexity of interaction. So we basically say that you need to handle this ad hoc, as you already do today. So what you do today probably is that you know about, because of your experience, about the typical interactions, like, for instance, battery life and performance. And you have ad hoc experience-based ways of dealing with this. And this needs to be, you need to do this still. We don't have a solution for it. But it gets soon a combinatorial explosion if you are going to handle everything. So as a future work, we have considered to try to simplify also this problem, but that's for future work. So, yes?
I'm again trying to put this in my perspective.
Hmm?
So I'd like you to sort of validate my thinking or tell me that I understood you wrongly.
Hmm?
If I understood you wrongly. But what you call quality requirements and non-functionals, I often see these things as functional requirements that are hidden. So if there's a non-functional requirement of performance, there really is a functional requirement the system should fail over when one machine dies and there's 10,000 users. So and if I understand this correctly, so this is applicable to functional requirements that are not discrete. It's not on or off. It's rather a sliding scale.
Yeah,
am I missing the point?
It's a very good question. Did you hear the question? No? So the question is, well, some functions are related to qualities, and actually the other way around. Some qualities are related to function, and it's actually not a clear cut between what's functional and what's non-functional. And am I understanding you correctly that this is about things that are on a sliding scale rather than on-off? So the basic answer to your question is yes, but I will complicate the picture a bit. Let's take security, for instance, a very big area of quality. We could talk about security on a sliding scale, for instance, measured as the number of hours it takes to break into a system. But almost every time the quality requirement manifests itself into a function. You will get login, you will get encryption, you will get yeah.
Hidden functionality.
Yeah. So if it's the quality who is hidden or if the functionality is hidden, I mean that can differ. I mean, I think there are many cases where you have functions where you have hidden quality in the terms of that you have never explicitly said what you mean with quality, but you have a lot of functions. And you can have the other way around, that you want the quality, but you haven't really analyzed this in terms of which functions can support this quality, and there can be alternative functions that can support the same quality. So
that's likewise for a functional feature,
yeah.
functional requirements.
So, yeah, that's one complication. The other complication is that quality requirements can be either holistic or particular or detailed. You can have some quality aspects that really strike on the whole system, and security is one of them, because you cannot have an unsecure part of a secure system. Other parts, like performance, can be very local. You can have very slow performance on some part of the system and very fast on others. So there are many different aspects of quality that complicates the picture. What we are saying with the QUPER model is that if you can define some kind of scale to characterize your quality, you can use the breakpoints, etc., to make better decision making. That's what we're saying. But we're not actually hiding this problem in that sense, but we are simplifying it when it's possible.
We're running out of time.
So one last question or not?
Okay.
One short?
Very short.
No. The coffee is coming, yes.
If anybody wants to continue discussion with Björn,
I will be here for a while, so you can discuss at least at the lunch. Yes, I will be here in this room during the break. So, Thank you very much.